Chapter 8 Programming Languages. Learning Objectives. Understand types of computer languages. Identify low-level languages. Describe machine language. Define assembly language. Explain high-level languages. Distinguish language translators. Just like we communicate with each other using languages like English or Hindi, computers have their own special languages too. Computers understand instructions that are given to them. These instructions are written in languages that computers can understand and execute. These languages are called computer languages or programming languages. The individuals who write these programs are called programmers. Types of computer languages. Computer languages can be broadly classified into two categories. 1. Low-level language. 2. High-level language. Computer languages. Low-level languages. Machine languages 1GL. Assembly languages 2GL. High-level languages. Third general languages 3GL. Fourth general languages 4GL. Fifth general languages 5GL. Low-level languages LLL. Low-level languages are closer to the machine's hardware and are more difficult for humans to understand. They include machine language and assembly language. Machine language. Machine language is the lowest level of computer language. It is the only language that a computer can understand directly without any translation. Machine language consists of binary code, which is a series of 0s and 1s. Every instruction in machine language is represented by a unique combination of these binary digits. Did you know? Machine language is also known as the first-generation language. Assembly language. Assembly language is a low-level language that uses symbols and letters to represent machine language instructions. These symbols and letters are called mnemonics. Assembly language is easier to understand and write than machine language. However, it still needs to be translated into machine language for the computer to execute it. This translation is done by a program called an assembler. No more. Mnemonics in assembly language are shorthand representations of machine language instructions. Here are a few examples. ADD adds two values. SUB subtracts one value from another. MOV moves data from one location to another. Load loads data from memory to a register. Store stores data from a register to memory. Jump jumps to a specified instruction address. High-level languages HLL. High-level languages are more user-friendly and easier to write than low-level languages. They use English-like statements and are independent of the machine. High-level languages need to be translated into machine language by a compiler or an interpreter before execution. High-level languages can be further categorized based on their features and purpose. Third-generation languages. Third-generation languages are the most common high-level languages used today. They offer structured programming constructs like loops, conditional statements, and functions. Examples of third-generation languages include C/C++, Java, BASIC, COBOL, etc. Tidbit: C language developed in the 1970s. it is widely used for system software and application software. Fourth-generation languages. Fourth-generation languages are designed for specific purposes, often focusing on database management and report generation. 4GLs are even more user-friendly than 3GLs and often use a declarative style where the programmer specifies what needs to be done rather than how to do it. Examples of fourth-generation languages include SQL, Structured Query Language, Python, Ruby and Perl. Fifth-generation languages. Fifth-generation languages are still emerging and aim to make programming even more accessible by allowing users to solve problems using visual interfaces or natural language. 5GLs often rely on artificial intelligence and machine learning techniques to automate tasks and generate code. Examples are still evolving but could include Prolog and Mercury. Language translators. A translator is a program that converts instructions written in a programming language into machine language which a computer can understand and execute. There are three main types of translators: assembler, interpreter, and compiler. Assembler. An assembler translates programs written in assembly language into machine language. The assembler converts mnemonics instructions into machine code, allowing the computer's hardware to execute them. Interpreter. An interpreter converts high-level programming language code into machine code. An interpreter reads each line of code, analyzes it, and performs the corresponding actions immediately. If there are errors, the interpreter stops execution and reports them. When you run a Python program, the Python interpreter reads each line of code and executes it. Compiler. A compiler translates an entire high-level programming language program into machine language before the program is run. The compiler reads the source code, translates it into machine code, and produces an executable file. The main advantage of compiling a program is that it generally runs faster than an interpreted program because the translation is done the entire program at once. Differences among assembler, interpreter, compiler. Feature: assembler, interpreter, compiler. Input: assembly code, high-level code, high-level code. Output: machine code, directly executes code. Machine code executable. Execution: not directly executed, line by line, after compilation. Error detection: before execution, during execution, before execution. Speed: fast, slower, faster. Chapter Essentials. Computers use programming languages to understand instructions. Programming languages are categorized into low-level and high-level. Machine language uses binary code, 0s and 1s. Assembly language uses mnemonics for machine instructions. High-level languages use English-like syntax. Third-generation languages include C, Java, and BASIC. Fourth-generation languages focus on databases like SQL and Python. Fifth-generation languages involve AI and natural language. Assemblers convert assembly code to machine code. Interpreters execute high-level code, line by line. Compilers translate entire programs Before execution,